So for number 50, we want to find if this sequence over here converges. And now a sequence converges if it tends to a defined limit as n approaches infinity. So what we're going to do here is we're going to take the limit as n approaches infinity of our sequence, so ln of n squared divided by n, and we're going to see if it outputs a limit for us. And so when we take this limit, it's going to be ln of n, which is infinity, over infinity. So this is going to give us infinity over infinity. This is undefined because we don't know whether the infinity on top or the infinity on the bottom is going to win, right? It's like a tug of war, and we need to decide which side is going to win. And so this here is undeterminate form, so we can use L'Hopital. However, L'Hopital is for functions, right? But the thing is that a function in a sequence, so if we were to take the function, say 1 over x, and the sequence 1 over n, so 1 over x would go like this, right? And so it is, we can see here that it is defined for all points, all real points, from excluding 0 all the way out to infinity. And now the sequence, it would just be the natural numbers. It behaves the same way, but instead of being defined for every single point, it is just defined at these natural numbers, right? At n is equal to 1, n is equal to 2, and so on. But we can see here that they are essentially the same thing. They have the same behavior, they're heading to the same place. The only difference is that the sequence only takes natural numbers, so it is discrete. But we can see that they're heading to the same place, so they must have the same limit, right? So we're going to say, okay, then this is the limit as x approaches infinity of ln of x squared divided by x. And this we can work with. So as we've shown, this is infinity over infinity. So we're going to use L'Hopital. So we're going to take the limit as x approaches infinity of ln of x squared divided by x, and we're going to take the derivative of the one on top divided by the derivative of the one on the bottom. So the derivative of the one on top is going to be, because we have a chain rule, this is going to be the limit as x approaches infinity of, the chain rule here is 2 ln of x times 1 over x, because it's the derivative of the outside times the derivative of the inside, and then the guy on the bottom, the derivative is just 1, right? And so if we rearrange this, this is going to be the limit as x approaches infinity of 2 ln x, and this guy goes on the bottom, right? This 1 over x. And this is still, if we evaluate this, this is 2 times ln of infinity over infinity, so still infinity over infinity. We have to use L'Hopital again. So we say use L'Hopital again, and so we take the limit as x approaches infinity, and now we're going to take the derivative of the guy on top and the derivative of the guy on the bottom once more. So the derivative of 2 ln x is going to be 2 times 1 over x divided by the derivative of the guy on the bottom is going to be just 1, right? So this is equal to the limit as x approaches infinity, we're just going to clean this up, of 2, this 1 over x goes on the bottom, and then when we take this limit here, it's going to be 2 divided by infinity, and that's just going to be 0, right? So we've shown that this limit here is equal to 0, and so because the limit of this sequence is equal to 0, we can say that an tends to 0 as n approaches infinity. So we're saying this sequence does have a limit because we found the limit of the function, right? We know that the function and the sequence, they go to the same place, and the limit of the function is 0, so the sequence is, the limit is also 0, and so it does, so an converges. And that is it for number 50.